In this video, we are going to finally learn our last rule or shortcut for differentiation, and that is the chain rule. And the chain rule is how we take the derivative of a function when our function is a composite function. So when I say composite function, that means we have a function within a function. It's kind of like the layers of an onion. We have one function nestled in the other. And so when we want to find the derivative of a function that's like that, we have to use a special rule. We're not going to be able to just rely on the power or product or quotient rule to do that. So this is somewhat of a unique situation. And this is probably the trickiest differentiation rule out of all of them. So it is super, super important that you just practice like crazy these kinds of problems before the AP test, because I can almost guarantee you will have to use the chain rule at least once on the AP test. So it's really important that you feel confident about it. So when I say a composite function, and I mean a function inside a function, that would be if I had something like y equals cosine of 3x. So what you might notice here is that I'm going to refer to cosine as my outside function and 3x as my inside function, because the 3x is kind of the thing that goes into the function, and then cosine is what happens next after we put 3x in. So we call 3x our inside function and cosine our outside function because that is the order in which operations happen. If we were to plug a number in for x, then we would multiply it by 3 first, and then we would take the cosine of it. So this is kind of my inner function that's kind of nestled in, and then cosine is my outer function. Another example would be, say I defined some function f of x, and f of x was defined as 1 over x. And then I'm going to also define another function, g of x, and g of x is going to be defined as x to the fourth. And I wanted to know what f of g of x was. So what this is saying is plug g of x into f of x. So your input is the function g of x. G of x gets inputted into the function f of x. So what this would look like is we'd have the function f of x, which is 1 over x, but instead of plugging in an x value, we are going to plug in the function g of x. And the function g of x is x to the fourth. So if we plug in x to the fourth and for x into this function, we're going to end up with 1 over x to the fourth. So this is the whole idea behind a composite function, is that we kind of plug one function into the input of another function, and so we can identify an inside function and an outside function. So being able to identify what the inside and outside function is so important that I've written out a few examples here where we're just going to go through and identify which is our inner and our outer function, because it is crucial that you are able to understand that idea if you're going to apply a chain rule. So what I'm going to do is I'm going to label or draw on my outer function in purple, and then my inner function is going to be in blue. So if we look at this first example here, sine of x squared plus 3, you can hopefully see that our inner function, the one in parentheses, is going to be this parabola, and then our outer function is going to be our sine function. So we're inputting kind of a parabola, and then our outer function, we're taking the sine of it. So our outer function is going to be the sine, and then our inner function is going to be this x squared plus 3. And it's going to be a similar thing down here where we have tangent of 2x. Our outer function is going to be tangent, and then our inner function is going to be the 2x. So again, we're inputting this function, and then this is the function that happens after. This next example over here is a bit trickier because it's a little less obvious than our trig functions over here. So in this example, what our outside function is going to be is actually this squared function right here. Because what we're doing is what's in parentheses is what we're inputting, and then after we input something, we square it. So whatever we put inside is going to be our inner function, and then after we plug something in, we're gonna square it. So that's why this squared is kind of the outer piece, is because it happens after you plug something into the inside here. And so a similar thing is gonna happen down here. The fourth is going to be our outside function, because after we plug something in, we always raise it to a fourth power. And so then our inside function is this. This is what gets plugged in, something cubed. And then lastly, down here, this is also a bit tricky, but our outside function is going to be this square root. So I'll just go over it in purple. So our outside function is the square root, again, because that happens after we plug something in and square it and add 5, right? So this parabola right here is our inside because that happens first, and then the square root is going to be our outside function. So now we're going to get to the actual differentiation part. And so what the chain rule says is if you have some inner and outer function, so in this case, in this formula, our inner function is g of x and our outer function is f. If you have some composite function like this and you want to take the derivative of it, what you do is you take the derivative of the outside function, that's this f prime here, and then you keep whatever was on the inside the same, and then you multiply by the derivative of the inside. So that might seem confusing now, but hopefully after a few examples, you'll see what they mean by this, and this is a pattern that you're going to get really, really familiar with as you do these chain rule problems. So if we have the function y equals, and I'm going to write my inside function in blue, so y equals 5x cubed plus 3x, and then that is all going to be raised to the 5th. So this is my function right here, and I want to take the derivative of this. I want to find y prime. So hopefully you can see that this purple right here is our outside function, and then everything in blue is our inside function. So what the chain rule says is that if we have this composite situation, we're going to start by taking the derivative of our outside function. Now remember, our outside function is just this 5th right here. So our outside function is essentially something to the 5th power. We're plugging in something in these parentheses here, and then we're raising it to the 5th power. So if we had an example just as simple as this, and we took the derivative of it, it would be 5x to the 4th, right? We just use power rule on it. So a similar thing is going to happen here. We're going to bring the 5 down, just like power rule tells us, but the chain rule says that whatever is on the inside stays the same. So all this stuff on blue is our inside function. So that's all going to stay the same. So we're still going to have 5x cubed plus 3x. And then the power rule tells us over here, we move the 5 out front, that's that, and then we subtract 1 from the exponent, so that's going to become 4. So what I did right here is I used power rule only on the purple function. I brought the 5 down out front and then subtracted 1 from the exponent, but everything in blue here stayed the exact same because that's what chain rule tells us to do. Take the derivative of the outside, and then everything on the inside stays the exact same. So that was this first part. But now we need to multiply all of that by the derivative of the inside. So this is where we take the derivative of the inside, and the inside is this blue piece. So we need to multiply everything we have by the derivative of the blue piece. The derivative of 5x cubed is going to be 15x squared, and then the derivative of 3x is going to be 3. So this piece right here was the derivative of the inside, and it's being multiplied by this first term. So this is what the chain rule says, is that if you have some outside function, do the derivative for that, whatever was on the inside stays the exact same, and then we multiply by the derivative of the inside. So hopefully as you see some more examples, you'll kind of get the idea and get the pattern down. So here's another example where we're going to be using the chain rule, and we know we need to use chain rule because, again, we have this inside function in blue and we have this outside function in purple. So the chain rule tells us that if we want to find y prime, first we're going to take the derivative of the outside function, and our outside function is the squared function. So if we apply power rule, that 2 is going to come down out front. And then chain rule says that everything that was on the inside stays the exact same. So I'm going to rewrite everything on the inside. And then power rule tells us that since I had a 2 up here before, I need to subtract 1 and make that 1. So what I did is I took the derivative of the purple using power rule and kept the inside the exact same. I kept my 2x squared plus 4 the same. And now chain rule says we need to multiply all of that by the derivative of the inside. So all of that is going to get multiplied by the derivative of 2x squared plus 4. And the derivative of 2x squared is going to be 4x using power rule. And then the derivative of any number or constant is just 0. So plus 0. You don't have to write that plus 0, but for clarity's sake, I'm going to put that there. So this right here is our y prime using the chain rule. So this is the last example that we're going to look at. We have y equals the square root of x cubed minus 4x, and we want to take the derivative of it. So here our inside function is in blue because that's what's going to happen first, and then our outside function is the square root. Now hopefully you remember from the other videos that whenever you see a square root in calculus and derivatives are involved, you always want to rewrite that square root as a power first. That should be the very first thing that you do because it'll make using power rule a lot easier. So what we're going to do is we're going to rewrite y, and we're going to rewrite it as a power. So x cubed minus 4x, and then that's all going to be raised to the 1/2 power. And so this was just using one of our exponent rules. So always in calculus, when you see a square root, rewrite it as a 1/2 power. So now we're ready to take the derivative of this. So y prime is going to be, chain rule tells us we first need to take the derivative of the outside function, so that 1/2 is going to come down out front. And then chain rule tells us that we need to keep the inside the exact same. So we're still going to have x cubed minus 4x. And then we need to change this 1/2 exponent. We need to subtract 1 to make it negative 1/2, because that will finish off the derivative of our outside. And then chain rule says that we need to multiply all of this by the derivative of the inside. So the derivative of the inside is going to be 3x squared minus 4. So that right there is our y prime. So hopefully you can kind of start to see the pattern that's happening here. Again, this rule is just going to take a lot of practice, and in future videos you'll see that we're going to combine all the rules. You might have situations where you're using chain rule, product rule, quotient rule, and power rule all in one problem. So these chain rule problems will definitely get more complicated, so it's really important that you get a good grip on them now. As always, if you have any questions or you want to see any tricky examples, make sure you leave those in the comments, and don't forget to subscribe.